So let's see. First today is a reciprocal vector. Number is 7, 8 or 9. This is reciprocal vector, and we know that I have number 5, scalar 5. Its reciprocal is given by 1 upon 5. So this is to be reciprocal of scalar. Likewise here also in vectors also we can have reciprocal vectors. Okay, so if a bar is the vector given, its reciprocal is a bar dash raised to minus 1. So this a bar minus raised to minus 1 is called as its reciprocal vector, or it is just by nothing but 1 upon vector a bar. So 1 upon vector a bar is said to be reciprocal vector a bar. And remember here we can make a small change here. This a bar inverse also can be written as, if you remember, it can be written as, I can write here to be this vector a bar divided by its magnitude. Okay, and its magnitude. So in a inverse bar, or a bar inverse is equal to vector a bar divided by its magnitude. Now here you will find that this a bar and this a magnitude, this will be taken to be in such a manner that this actually I'm not need to write this. This is e cap into its unit vector. So this is n cap. So this is can be written as a inverse, can be written as n cap, its magnitude, because that shows you the direction, whereas this a bar, this modulus a bar is its magnitude. So n cap upon a bar. So you can write this. It is n cap upon a bar, a magnitude, and as already we have known, this n cap is given by vector a bar divided by its magnitude. So here I can write this as vector a bar upon magnitude a, earlier there, multiplied by magnitude a, or this is nothing but vector a bar upon a square. So this also is written to be reciprocal of this vector. Okay, so a cap inverse is equal to n cap upon modulus a. That can be written as, n cap can be written as vector a bar upon modulus a. So this final becomes a bar upon a square. So that is said to be reciprocal vector of this vector a bar. Okay, now the magnitude and of the reciprocal, the magnitude and reciprocal. Okay, one more very important thing we have to discuss: the magnitude and reciprocal. Magnitude and reciprocal of the magnitude of unit vector, of the magnitude of unit vector. Okay, this is all in general vector. Now let's see what happens to the unit vector. Unit vector being unity, that is 1. Being unity, that is the unit vector is reciprocal to itself. Unit vector is reciprocal to itself, and it is said to be self-reciprocal, and is said to be self-reciprocal. तो स्वतःचाच reciprocal vector आहे. Okay, unit vector. Why? I can show here as per my definition. This, for example, j cap inverse is equal to, I can write here to be 1 upon modulus j cap into unit vector j cap, like this. जसं मी येथे लिहिले तसंच हे लिहिलं तर असं असेल. And here I can write this is 1 upon j cap modulus into, this can be written as vector j cap divided by its modulus j cap, and therefore now here will be modulus j into modulus j. It is 1 into 1, and that's what again j cap. So here j cap inverse is equal to j cap, or that can be also shown to be I cap inverse is also equal to I cap, and k cap inverse is also equal to k cap. That can be shown for others. So unit vectors are reciprocal of itself. Now let's go another important property, that is rectangular components of vector. Rectangular components of vector. Rectangular component of vector. Again, remember, all this is just revision. We are not learning anything new. Okay. So for example, in 2D Cartesian space, the Cartesian coordinate, where x and y are only two coordinates we are having, we can write vector A bar is equal to IAX plus j cap into AY. I can write this as a vector here. So naturally, AX, vector AX bar is called to be I cap into AX, magnitude and direction. Similarly, AY cap bar is also given by j cap into AY. Okay, so these are called rectangular component. These are called as rectangular components. Okay, if we draw this diagram here, this is x, this is y, and suppose this is vector here, it is shown by vector A bar. Now to get its components, I have to draw its intercept here. So this your origin 0 0. So this vector is called as its AX bar, and this vector is called as AY bar, and therefore AX bar is given by I cap into AX and AY is given by j cap into AY. Vector AX bar is I cap into AX. AX is magnitude, I cap is direction, and then product of this becomes this rectangular component AX bar. Similar is the case here, j cap is its direction, AY is magnitude, product of this gives me AY bar, and that is what is rectangular component. So this vector A bar can be resolved in these two components as shown by AX bar and AY bar, and these are called as its rectangular components. Okay, so I should write here to be AY bar. Okay, these two vectors, this is AY bar and this is AX bar, and I can use here. So again, remember, this is nothing but AY, this is AX, this is right angle. So I can write here this magnitude of this E is equal to root of AX square plus AY square. Remember, this is scalar, magnitude is scalar, and if this angle is theta again in this diagram, this is theta, I can find out tan theta is equal to this is AY upon AX magnitudes. Okay, this is AY upon AX, magnitude of AY upon magnitude of AX gives you tan theta, or theta inverse is equal to, theta is equal to tan inverse of AY upon AX. That is the method with which we can calculate this particular vector here. And if we in the 3 dimensions, okay, in 3D Cartesian space, naturally we write vector A bar like this, IAX plus j cap AY plus k cap AZ. Now there are 3 different directions, x, y and z, therefore IAX, JAY, KAZ, these are the components, and therefore AX bar is equal to IX, AY bar is equal to JAY, and AZ bar is equal to KAZ are the rectangular components. Okay, so therefore AX bar is equal to I cap AX, then AY bar is equal to j cap AY, and AZ bar is equal to k cap AZ are rectangular components. We always know that I, J, K are unit vectors, they are perpendicular to each other, therefore AX bar, AZ bar and AY bar, these are also rectangular, they are also perpendicular to each other, and therefore they are the rectangular components. And here magnitude. We require this number again lot many times. Magnitude A is given by square root of ax square plus ay square plus az square. Ay square plus ax square plus ay square plus az square. For any given vector, its magnitude is given by square root of square of the x component, square of the y component, and square of the z component. And another very important thing we have to discuss here, again just same thing, that is a resolution of vectors, resolution of a vector. So let's see. For that, draw this diagram again. A diagram is a bit difficult in the sense we have to draw this diagram. These are the three different axes as I shown. So this is z axis, this is y axis, and this is x axis. So for example, I am showing this point to be a point P, which has its coordinates x, y, and z. Now draw a vector from this to this. This is called as my a bar, vector a bar. This is position vector of this point P from the origin as shown by this. Now we can take its ह्या a कॅपचा टिपचा ह्या प्लेन एक्स झेड वरती मी एक पॉइंट घेऊ शकतो. सो दिस इज सेट टू बी प्रोजेक्शन. ओके, फॉर एक्झाम्पल this projection here y component is 0, so x 0 z, this is the projection of this. I can take here this component or projection of this point on this xz plane as shown by this point. So draw a vector from this to this. Now this is said this vector, okay, another vector, it is said to be projection of this a bar on this xz plane. So this is a projection, and here again I can take from this, I can draw here a perpendicular. Similarly here also I can draw a perpendicular. So this component is nothing but az, this component is nothing but this ax, this component from here to here, this is ax, and therefore this is triangle of addition of vectors gives you az plus ax, or ax plus az is this component. Actually all these are vectors. This is vector, this is vector, and this is also a vector. So I got az, this is ax, and similarly I can draw a perpendicular from this point, this tip to on this axis, and this gives me ay bar. So I got az bar, ax bar, ay bar. These are called to be resolved components of the vector a bar along three different directions. Okay, so we have right here सेम रेक्टेंगुलर कॉम्पोनेंट जे आपण वरती म्हटले तेच इथे घ्या केले. हियर ax bar, ay bar, and az bar are called resolved components or resolution components of vector a bar in three different directions. So that gives you this ax bar, az bar, az. That is the resolution. Try to understand. Any vector can be resolved in different directions as per your choice. If I am going to get this vector a bar in this Cartesian coordinate system, its coordinates are p of x, y, z. So that a bar represents a position vector of point P. Now this vector a bar can be resolved in these three components by drawing a simple geometrical diagram wherein we have to get a projection of this point P bar on this xz axis, that is q, x, 0 and z, and this location of that can be its position vector also can be calculated, and that position vector is nothing but az bar plus ax bar. And here from this diagram we can find out a bar, az bar, ax bar, and ay bar are the resolved components of this a bar. So any vector that can be resolved in its component as shown by this simple diagram, that is to be understood. Okay, so these are the few very basic preliminary things related to vectors. Now we'll go next, another important and simple things, that is called as algebra of vectors. Algebra of vectors. Algebra is nothing but addition, subtraction and multiplication. So first of this is addition of two vectors. Addition of vectors. Addition of vector. All you are getting my sound?
Yes, sir.
Yes, okay. Now there are three different ways in which vectors can be added. Okay, so I will write here. There are three different ways. Three different ways that we can add vectors. We can add vectors. Okay, now first one is called as triangle law of addition of vector. TRI, triangle law of addition of vectors. Addition of vectors. Second is the parallelogram law of addition of vectors. Parallelogram law of addition of vectors. Second method. And third one is, if I am given more than two vectors, then we have to use a one law, that is called as polygon law. Polygon law of addition of vectors. Polygon law of addition of vectors. Merely I know that all this is just repetition and repetition. So now how I have to go? So in case of first then triangle law. Okay, triangle law of addition of vectors. Triangle law of addition of vectors. So it's very simple case here. I am given vector A bar is like this. Then we have been given vector B bar is like this. So this is vector where it begins, where it ends, this vector B bar is there. Now in that case, complete this triangle starting from origin of A to the tip of this B. Okay, so I am writing it here, this B. Now this is said to be the vector law or the triangle law of addition of vectors. So this is my A bar, this is B bar, and this is I can take to be a C bar, and therefore we can go here, C bar is equal to A bar plus B bar. C bar is equal to A bar plus B bar. And if someone goes, समजा एखाद्याने इथून सुरुवात केली आहे की नाही, हा वेक्टर मी आणि इकडं वेक्टर काढला, असा हा वेक्टर इकडं काढला, so again I'll get this plus this, so I'll get exactly similar, इकडेही मला तसंच मिळेल. So I can write C bar is equal to B bar plus A bar 2 असं पण मला लिहिता येईल. So that is equal to B bar plus C bar. Okay, in that sense this vector addition is said to be commutative. Vector addition is commutative. C-O-M-M-U-T-A-T-I-V-E. Commutative means order is not here important. Either you can take A bar plus B bar, or you can take B bar plus C bar. Geometrically we are doing same thing. We are going to get the C as a resultant of this addition of these vectors A bar and B bar. So this triangle law of addition of vectors is a simple process where we have to complete a triangle starting from starting point of vector A to end point of vector B bar, and that connecting these 2 points, that is a new vector which is thought to be C bar, and this C bar is given by this diagram as shown here. So this is the triangle law of addition of vectors. Okay, now the second method, as I discussed here, we have mentioned there, this is said to be parallelogram method or addition of vectors. Parallelogram addition of method of addition of vectors. Okay, now there is no need to write anything, definitions and so many things here. For that I will draw a simple diagram as shown here. So this, draw a diagram along with me. I am having one vector as shown by this. There is another, this is, suppose this is vector P bar. There is another vector which is gone in this direction, and that is going to be Q bar. Okay, then extend this further and get projection of this point here on this. You'll get this projection. So I'm calling this to be point O, this is A, then this is point D, this is point B, and like that. So here also I can go for this. So draw a parallel to this या वेक्टरला, म्हणजे आपला Q वेक्टर आहे त्याला एक वेक्टर पॅरलल काढा. This will show this to be a parallel vector here, and draw a parallel to this too. And here I can get this is the resultant of this. I am completing this parallelogram, and this R bar is the resultant of this. Exactly the method here we have done, and this method here we have done just same. त्याच्यामध्ये काही फरक नाही. You can take this angle to be alpha, this angle to be beta, and this total angle, this is to be theta. So theta is equal to alpha plus beta. So again this angle will be theta. This is going to be 90 degrees or perpendicular, and therefore from this we can write a very simple relationship. What is that relationship? This becomes, this is R bar, this is P bar, plus this some additional component, and this is what, another component. So I'll get this component. मला खरं तर हा component ची व्हॅल्यू काढली आणि या component ची व्हॅल्यू काढली. This plus this square plus this square is equal to R square. So I'll get a relationship which is where we are using this Pythagoras law to get the square of the hypotenuse, that is R square is equal to P square plus this component plus this square, this component, and that's what gives me a some number here. Now this is again a right angle triangle. You can find this to be theta, and this is vector Q bar. This vector is our Q bar, and this, आता मला हा जर कॉम्पोनंट काढायचा असेल आणि तसाच हा कॉम्पोनंट काढायचा असेल, I can get sin theta is equal to this dB divided by this vector Q bar. Similarly, I can get cos theta is equal to this side, so it is ED upon, I'll get this to be again Q bar. So I'll get dB is equal to, vector dB is equal to, I can get this magnitude of dB is equal to sin theta into Q bar, as well as this ED is equal to cos theta into Q bar. So therefore I'll get now this from, therefore this OD is equal to vector P bar plus this vector ED bar, and therefore it is P bar plus, this is cos theta into Q bar. Similarly, I'll get this BD तो अपन तो काढलाच आहे. BD is this, and BD bar is equal to, DB bar is equal to sin theta into Q bar. Okay, now you can use here, I can get here this side. So therefore, using Pythagoras theorem of triangle, right angle triangle, Pythagoras theorem of right angle triangle, just try to write this relationship. I'll get OD square, your R square is equal to OD square plus BD square. So write this OD and BD there. OD is obtained to be P plus cos theta into Q square. Okay, now I'm taking only direction, magnitudes, not directions have not been taken there because it's a square etc. So direction doesn't come here. And plus BD is equal to sin theta into Q square, magnitude. So make this square, it will be P square plus twice PQ into cos theta multiplied by plus cos square theta into q square, cos square theta into q square, and plus this is sin square theta into q square. Therefore, writing this, it is p square plus, now I can take this term, two terms here, so it is q square into the bracket cos square theta plus sin square theta, and plus twice pq into cos theta, and therefore further relationship is r square is equal to, I can write this is p square plus q square plus twice pq into cos theta. This is one more relationship, and therefore I can get this vector r bar is square root of this p square plus q square plus twice pq into cos theta. You'll find that this method is bit difficult as compared to earlier addition of triangle law by addition of vector. So remember this relationship, r square is equal to p square plus q square plus twice pq cos theta. This is one way, and if theta, angle between p and q, is known, we can find out